All right, so let me log in. Okay, so let's go to EKS. Elastic Kubernetes Service. Okay, so now let's just pretend as if you want to create a cluster. So when you look at it now, the problem we actually had the last time was this particular role. So I had to create different role. So while you are trying to create a Kubernetes cluster, you have to specify a role. Okay, so you have to specify a role. And if you choose not to specify a role, let me just put test here. If you choose not to specify a role, I think it won't allow. It's going to ask you to create a role by fire by force. Okay, so now after creating this role, how do you specify? How do you attach this particular role to the user that I am using to log into my Kubernetes? That was actually what the problem is. Now, this is my EC2 instance. This is my EC2 instance. If I run, if I run AWS configure, you know what this AWS configure actually means? It's going to ask you to specify you remember last time we actually create IAM role. From that IAM role, we generate the access key and the secret. That is what you are going to use to programmatically log into your AWS. Okay, so now look at it now. It's asking me for the access key, and then there's already a default that I've actually specified before. That's why you have this. Because I've done it before, that's why you have this. So then the secret key, so it's telling me the secret key that I have provided before ends with this. I'll just type enter. Default region, which is this region that I specified before. So now, this particular user, how do I apply that role to that particular user? That was actually the challenge that I had yesterday. Okay, so where's even this command for checking this user? It's stc AWS. Okay, this get caller identity. So now it's telling me this particular user. Look at this user. I created the user called DevOps. This user DevOps, how do I attach that role to this particular user? That was what the challenge was. So what I did was I just had to create another Kubernetes cluster. Using command line. Then what I noticed is it automatically created a role. So where is the role? Okay, look at it. It automatically created the role itself. So this is the role that is created. And with that, it allowed me to easily log in using this particular user to be able to do anything on that on the Kubernetes cluster using this particular user. So now, how did I actually create? How was this created? Let me show you how it was created. So I have it here. So this is the command I was talking about, ekctl create cluster. ekctl create cluster. Then what is the name of the cluster? DevOps. Then which region? This is the region. And then which version do I want to create? Version 1.23, which is the same thing that you have here. You know, when you want to create a cluster, it just asks you what is the name, the version. So the only thing I didn't just specify its role, and then it automatically attach a role. I don't know if you get what I'm saying. You know, when I'm trying to use this console, it's compulsorily asking me for role, right? I don't know if you, hello, can you hear me?
Yes.
It's compulsorily asking me to specify a role, but when I use ekctl, I didn't specify any role, and then it automatically created a role for me, you know, and with that role, this user can easily access that particular role. So this user DevOps was able to easily access that role, okay? So that was how I created it. So now, if you want to create your own cluster, you can just do ekctl create cluster this. Okay, so that's our first option. So for practice sake, probably you don't want to spend money, because if you're running Kubernetes, you definitely spend money on AWS. So if you have a few dollars to spare, you can just run this yourself and create a Kubernetes cluster. Then the second option is you try to set up a Minikube on a Linux machine. Okay, so you can set up a Minikube on Linux machine. And then the third option is, I think I shared a playground. The last time I actually shared a playground that you can use to run a Minikube. Okay, there's this online playground, Kubernetes playground. And then I actually, I discovered Kubernetes also has another playground. So you can also follow this. Let me share it with you. So this is another one I actually noticed I can use to just play around. So I'm sharing it on the charts already. So this is for Kubernetes tutorial. So we have create cluster. So if you want to learn Kubernetes, so let's click on learn Kubernetes once you open. So it's telling you we have 6 modules: create a Kubernetes cluster, deploy an app. So once you click on create Kubernetes cluster, and it can now ask you to start interactively. So it's an interactive tutorial. If you want to learn more on Kubernetes anyway, it's an interactive tutorial. So just click to connect and then start. So with that, it's going to create a terminal for you, and then you can always play around with that same terminal. So if you have the time, you can also play around. You can also play around with this tutorial. It's going to teach you a lot of things. So this is Minikube. It's actually run using Minikube. So look at it. This is the Minikube version. I told you you can install Minikube on your machine. And again, I think there's another option that you can use. There's also Kubernetes for Windows. I think I have Docker for Windows. Yeah, you can also use Docker for Windows. Yeah, I think that one is pretty straightforward. Okay, so just try and download Docker for Windows. Once you open the Docker for Windows, then you can start your Kubernetes. So all these things, what I'm just doing so far is how you can just set up your Kubernetes. So we've not really started on the Kubernetes anyway. So all I'm just doing so far is how to set up a Kubernetes for you to practice. So when you come to, is it dev environment? Here is starting Docker. Maybe in dev environment, you should be able to see start Kubernetes. Okay, so I think here I have the virtualization running. I think maybe this, I have to stop it. No, let's not use that. Yeah? Is anyone saying anything? Sergio, please can you go on mute? All right, thank you. All right, so you can, if you like, you can go just any of the options you can just choose to go with. But for this class, I'm going to be using EKS. Once you actually install any option you choose, then we should be on the same page. Okay. So now, I remember from the last class. Let me check. I actually explained the concept of Kubernetes to us. Not this. I actually have this concept of Kubernetes that I tried to explain to us how Kubernetes actually work. So I have this diagram, Kubernetes architectural diagram. Let me quickly go over that again. So inside Kubernetes, this is an architectural diagram trying to explain what Kubernetes is all about. Okay, so now I told you Kubernetes actually works on client server architecture 1. Then it also has a control plane, which is like the engine room, and then which is what we call the master, and then we also have the worker nodes. So what is a master? A master is a VM, and a node are also sets of VMs. So so now what actually makes up a Kubernetes is at least a single master node and a worker node. Okay, so the master node is where you actually is like the engine room where you issue the commands, and then where all the commands are actually run is inside this worker node. There's this, there's something we actually call kubelet. So kubelet is another, is a process that actually runs inside the Kubernetes, okay, that actually collects a Kubernetes commands and, just try to execute it, inside the node. So we actually use that with the help of a kubelet. But anyway, let me just quickly go over this architecture. Now, look at this. At this end, we have kubectl. So kubectl is going to be our own tool that we'll be using to interact with Kubernetes. Okay. So now for you to use Kubernetes, you have to install kubectl. So which is what we have here. So if you want to do anything inside Kubernetes, you have to issue your kubectl command, restart. Sudo su. So now kubectl, this is it. So you have to install kubectl. I think I actually have, where did I share it? I shared it somewhere. Oh yeah, I think I shared it on the group yesterday, right? How to install all this. Yeah, I think I shared it on the group yesterday. Please, can you confirm receiving it? How to install kubectl?
Yes.
Yes, so I actually shared that. So kubectl is going to be our tool that we are going to use it to interact with Kubernetes. Okay, so no resource found. Okay, good. So now I will explain. So NS, I'll explain all this. Okay, fine. So now this is to show like we are connected. Okay, so now what do I do? All right, so I'm trying to explain this. So this is the kubectl. That's what we are going to be using to interact with the Kubernetes. Now, when we are using kubectl, it means you are interacting with API server. So when you're talking about API, what is API? API is an application programming interface. Okay, so it's like when you're talking about programming interface, you're talking about an interface. What is an interface? An interface is somewhere that is actually exposed, right? So now this is application program interface, now which is like Kubernetes program interface. Okay, so now once you are issuing a kubectl command, you are issuing it to this API server. So API server is going to collect the command, and interact with all these other components that is living inside the Kubernetes. You have the scheduler, you have the controller, then all these, you have the cluster residing inside the master. Then you also have kubelet running inside the node. Okay, so now basically what you just need to understand is this kubectl for issuing commands, okay, into the Kubernetes through the API server. So anything you actually run anything with kubectl, you are interacting with API server. Okay, so now let's go further. After understanding a simple Kubernetes architecture, it's as simple as you issuing a command to kubectl. Once you issue a command into kubectl, you are issuing the command to master, and then the master is the one interacting with other nodes. I told you nodes are different VMs using a scheduler. Okay, so a scheduler is actually used for communicating with other nodes. So this is just the simple architecture. Then now, the next thing now is let's go straight into using Kubernetes. Okay, so the first thing you really want to do, is, where is it? Okay, when you're working with EKS, so this is the command you actually use for connecting with a particular cluster. Okay, so let's assume I actually have another cluster that I really want to connect with. I'll just change the cluster name here. Okay, so now this is the command for connecting to a particular Kubernetes cluster. So once you issue this command, AWS EKS, so AWS is the AWS command line tool. So now we are interacting with Elastic Kubernetes service. Now we are telling it update kubeconfig. So when you issue this update kubeconfig, should I run this? When you issue this update kubeconfig, what you are telling Kubernetes is update the kubeconfig file, which is actually residing here. Which is actually residing here. This is the kubeconfig. So you're trying to update this kubeconfig file here. So if I cut it, this is the Kubernetes config file. Okay, so this is the config file for the Kubernetes. This is the cluster certificate, the API version. These are all the details that you are actually interacting with. Now, before that, there's also another configuration file which is living here, inside the home directory, AWS. So when you look at inside here, you see AWS config file as well. This is the config file for AWS, and this is the credentials, which I actually use to log in. So once you log in, using the command, the AWS config that I actually run earlier is going to create this file for you inside AWS, pwd. So you can see the directory. So you see, so this is the directory. Okay, so now with the understanding of this, let's go straight into Kubernetes. Okay, so now I think from the first class we had, I actually explained different kind of objects we have inside Kubernetes. I explained different kind of objects we have inside Kubernetes. We have the pod, we have the deployment. If you remember, you have the deployment, you have the service. We have the service. I'm just trying to list the major ones now that we need. We have the service, then we have the daemon sets. We have the daemon sets. We have the daemon sets. I will do a quick recap. We have the daemon sets. We have the replica sets. We have the replica sets. We have okay. Then we have the secret. We have the config map. We have the config map. I will explain all these things. We have the ingress. Okay. We have the ingress. All right. Then we also have, they are just advanced anyway. We have the persistent volume. We have a number of them. We have the persistent volume. We have the storage class. A lot of them anyway. In fact, myself, I don't know them exhaustively, but we also have CRDs anyway, custom resource definition. But now let's just talk about this. That's what we'll be needing for now. So what is a pod? You know, a pod is a Kubernetes object that is actually, you know, used for running what's it called now? A container. Okay, so when you have your pod running inside the pod, you can have one or more containers. Then so a deployment is more like a pod as well, but with a deployment you can also specify number of replicas. Okay, so now inside your deployment, you can use your deployment to actually run a pod. A deployment is actually used to run a pod, but then you can now use your pod to specify how many numbers of pods, okay, you want to run. So you can say, okay, run 2 number of pods. Okay, so now, like a pod is actually running a particular container. Then you're not telling a deployment like, okay, run 3 instances of these containers. The same container, run it in 3 instances. You know, that's where the concept of load balancing actually comes in, that you start spreading loads across containers. You get what I'm saying? Like if you're running a single pod, the load coming into the pod might be too much. So because of that, you can now spread the loads. Okay, with that you can use deployment to do that. So with deployment, you can run many instances of a pod, 2 instances, 3 instances, 4 instances, and all. It also helps you to do, there's something they call rolling updates. Okay, like this, you're updating, or you are deploying, maybe you're updating a deployment without having a downtime. With a deployment actually helps you. You can imagine like a Facebook now. If Facebook wants to deploy a new application, and during the course of deployment, Facebook actually went down. You find the times and, oh, WhatsApp did not go for 1 minute. I don't know, maybe I think it still happened like 1 month ago or something. Like just within 1 minute or 2 minutes, and people started reporting, hey, WhatsApp is down. Imagine because it's WhatsApp, because it's a big platform. So you don't have to wait till that, okay? So with this rolling updates, you can easily roll out your updates without it affecting the uptime of the application. Okay, so you can say, okay, without rolling update, you can update a deployment maybe to a particular region, to US, to Canada, whereas Nigerian people are still seeing something different. That's a rolling update. Okay, so that's deployment. Then with service, we are talking about service. When you are running a deployment is running a pod. So inside that pod, you are running different instances of pods. Each pod actually has its own IP. Okay, and now when an IP when a pod actually dies and it creates a new pod, okay, the IP changes. Now, how do you actually update that? You can't be manually updating every time. So with this service, there's something they call match label. Okay, so you use it to select a particular pod by name. So it's a way for specifying, okay, this service. Okay, what service is actually doing is service is actually used to expose a pod to an to the external world. Okay, when you run a pod is only accessible within a Kubernetes cluster. You cannot access it on the internet. So with service, you can easily expose the pod to the external world. How do you know a node is overloaded? Okay. There's something we also have something we actually call okay, now you can actually check the resource usage of a node, just like on your PC anyway. Just like on your PC, you can check when your PC is going slow, like something like your PC is actually overloaded. I don't know if you get what I'm saying. On your Windows machine, when you install too many applications, at some point it's going to be slowing down. Okay, you can do that. Then there's also various monitoring tools that you can actually use again for monitoring your resource usage anyway. If you want to monitor, especially Kubernetes, if you want to monitor Kubernetes resource usage, I actually use this tool anyway. I actually not plan to introduce us to it, but I can introduce us to it now. So if you want to work with Kubernetes, you can try to download Lens. With Lens, again, you can also be monitoring Lens. You can download Lens, Kubernetes Lens. So you can download it. You can be monitoring resource usage as one. And also, maybe when we work on Kubernetes, I can also try and set up some tools, some of these tools, so that you can have an idea about all these things are. There's also monitoring too. We have Prometheus for monitoring infrastructures. We have Prometheus. I'll try and install one of these tools so that you get familiar with it. So that's another. So what am I even saying before the question? Okay, so service is actually used for exposing service to the external world. Okay, so we have different types of service. We have different types of service. We have different types of service. We have cluster. We have cluster IP. We have node ports. We have node ports. We have load balancer. We have load balancer, and then we have external name. Yeah, external name. Okay, so maybe I'll try and explain this if you have time. But I want it to be practical. So now, when you're talking about daemon sets, please, I hope I'm communicating.
Yes, sir.
All right. Please, can I get another response? Am I communicating? Can you all get me?
Yeah, we can hear you.
Yeah, like, are you understanding what I'm saying?
Yes,
like, are you understanding so
yes,
far?
sir, we can hear
Or I'm
you.
too fast?
Right on, sir.
Concept, but at least you'll be grabbing it into Kubernetes.
All right, cool. So now we have daemon sets. So what is daemon set? I actually told you, I told you Kubernetes run with at least a single master and a single node. So you can have multiple nodes, like you can have 2 nodes, 3 nodes, 4 nodes running inside the Kubernetes cluster. Okay. So now, daemon set now, let's assume we have like 4 nodes running, and you want to monitor each resources inside each node. Okay, so instead of manually installing resources inside a node, you can just run it as a daemon set. So when you specify a daemon set, what daemon set actually does is, please run this instance of pod, okay, in each of these nodes, in each of these VMs. So I told you we have, let's assume we have 4 nodes. So now if you run an application as a daemon set, okay, you're telling it run each pod in each of these nodes. That means it's going to run 4 different pods. Each pod is living inside individual nodes. That is daemon set. Am I making sense? So now, if you want, let's assume you want to deploy a monitoring tool, so that's when you actually deploy a daemon set. Okay, so because you want to be monitoring individual nodes, individual resources usage inside a node. Okay, so that's when you actually use daemon sets. So that's it. Now, replica sets. Replica set is just a way for now I was explaining this deployment that you can specify replicas. Okay, 2 replicas, 3 replicas. So it's going to run it as a replica set. So it's going to like multiply. Okay, run 3 instances of these pods. So replica set is, okay, how many replicas? 2 replicas, 3 replicas, 4 replicas. That's replica sets. Okay, then secret. Secret is if you have a secret, confidential data, maybe username, password, your public, your private keys, and all. That's what you use a secret for. Okay, so there's another resources that we actually call secrets. Okay, then we now have config map. So config map is just a way of specifying variables. Hello, sir. So I don't know. This is going to be our 3rd class on Kubernetes. So I'm thinking right now, should we do this together, or I should just try to figure it out and we continue from the next class? Please, can I get our opinion? Hello.
Hello, boss. Yeah.
Yeah, so
Hello.
I said, what is happening now? I actually do not envisage what is really happening right now. It's a problem I never envisage anyway. So, of the opinion, I have 2 options now. Should we go through this together, or we should start from here next class? I should just try and work on it underground, and I will tell you what really happened, and then we continue. To be honest, I really don't like what is really happening myself.
Yeah, I get. It's bound to happen, though. You get. So
that's DevOps for you. Do you know? Let me tell you something. How did DevOps actually started? Do you know why DevOps started? What actually brought about DevOps is because in software development environments, it was discovered developers end up wasting time doing things like this than coding. Now, you employ the developer to actually to keep on working on your projects, maybe written in Python. And then the developer end up spending time trying to deploy servers, trying to manage servers, trying to come up with new features. Now, if it's a developer that is doing these things, you discover like the developer is not as efficient for what you really employed him for. You didn't employ him to come and be deploying server because this thing can really take time. I don't know if you get what I'm saying. Now, that's the concept of DevOps, to be able to upload the problem from developers, and developers can focus and DevOps too can focus on its own side. So this is DevOps. This is what you tend to see most of the time. So, but then this is actually a training anyway. So that's why I really don't want us. The training is just for you to quickly have a grasp of what is really happening. Okay, it's not for all the problems. So what I'm saying now is, should we solve it together, or I should just try to figure out what is happening and then we continue from the next class? I think we are about 3 year majority. We just go with the majority. What do you think?
For me,
I believe we can continue from next class, and what is happening now, I know there are 3 solutions to it, but it's going to be better we go with AWS Management Console. In order, like if we are creating the EKS cluster with the AWS Management Console, it's going to be far much more better, and I believe it's going to help us. But we can continue from next class in order to see if we can make use of other options as well. But I know using the AWS Management Console is going to work with AWS. But as well, we have Git, we have Terraform. So I don't know. That's my own opinion.
Yes. So the first class we actually used AWS Management Console as well. Anyway, that it didn't work for us. I said we used AWS Management Console. I was not able to connect to the cluster. I was not able to connect to the cluster because I use AWS Management Console.
Okay.
Yes, that was the problem. But then now, what I really noticed then was the reason why it didn't actually, it can work for me if I really want it to work. But the reason why I didn't make it work is because it doesn't make sense. If I want to use hammer and chisel method, it's going to work. Now, the reason why it didn't work for me is because it wants me, the particular user that I'm using to connect to the cluster. No, it wants me to use the particular user. It wants me to use the particular role. Okay, the particular role that I use in creating the cluster. It wants me to use it to access the cluster. Now, why do you want that particular role when I already give it administrative access? In the company, in the company I'm working on, now imagine if it's in the company that I'm working or in the company that you're working, you're not saying, oh, guy, you need to give me that particular role, otherwise I'll not be able to do anything. It doesn't make sense. So that was why I really didn't want to go through that method. Like, it doesn't make sense if you're telling me I must use that particular role. You'll be able to attach that role to any user, especially any user that has administrative access. What is the essence of administration? When you say something has administrative access, it means it can do anything. I don't know if you get what I'm saying. I'm an admin. As an admin, I should be able to do anything. You shouldn't tell me like I need a particular role again because I have admin access. When you go to the admin access we actually created now, that's why you actually have white card. We use white card. Let me share my screen so I can show you. We actually use white card. And you know what white card actually means? White card actually means anything. That's what white card actually means. Anything. So you're telling it like you should be able to access anything. You can see my screen.
Yeah, sure.
All right. Let me show you. So this is the role. We have different role now. So okay, now look at this. This is the role that I actually used to create the the cluster using admin console yesterday. When you look at it, where is inline policy? Is it rule? Okay. When you look at this administrative rule, later when I was even testing, I had to add administrative access. So look at it now. This is the inline policy. Action. This action means what can you do? Look at it and we say star. Star means anything. Then what resources? It means anything. Now look at this one that I just said, EKS, Amazon EKS cluster policy. You know, this is admin, right? Admin means anything. Okay, let me just show you the difference. Look at, for EKS, look at the action. So you have to manually start specifying it one by one. EC2, auto scaling. I don't know if you get what I'm saying. Elastic load balancing. So, but with
I do understand.
Admin, you say everything. That is what that means. You're telling me like it can do resources, everything. It can do action, anything. That is the essence of admin. So now I already have the user that already have administrative access. Then why are you still telling me I need a particular rule? Then I knew that was a problem on its own. But then I'll just try to figure it out anyway. The reason why I've not been really able to figure it out is I've not really worked with AWS EKS anyway. So there's always a first time. There's always a first time. I couldn't probably teach us with GCP because it's going to cost us. I couldn't teach us with OCI because it's going to cost us. And I choose to go with this, but this is what you're facing right now. So let me just figure it out. I thought I already figured it out anyway, but still not yet figured. Okay. And again, if you don't actually want to waste time, if we don't want today to waste, we can continue. What do you think? We can continue with this console. This is the console here. They give us everything we can work with here anyway. You know, we can always play around inside this console and it will not be wasted. I don't know if you get what I'm saying. So now, are you get what I'm saying? Hello?
Hello.
Yes. So I'm saying we can still make use of today anyway. If AWS console is not working for us till I figure it out, this is another console that we can make use of. This is the one from Kubernetes. We can also work with this anyway. So now, if you just run kubectl get nodes, kubectl get nodes, you already have it up and running. And let's assume we actually want to do our first deployment. Let's assume we actually want to do our first deployment. If AWS is, for me to just figure that out, let's just do this anyway to see how it goes. So let's try to create our first deployment. But I'm actually destabilized already anyway. I don't think I can continue with this because I didn't plan for this. kubectl get ns, just as I was explaining earlier, kubectl get ns. So you see, these are the default namespace that came with it. So kubectl, create namespace. Let's call it DevOps. Okay, namespace created. So let's see. So you see, this is DevOps. So now let's try to make deployment and see, paste. So you are going to create 2 deployments, then the other one inside namespace called DevOps. All right, so now let's get the deployment. Let's see what we have, which is kubectl get deployment. -A. Okay, so you get this, right? You know what is happening here, right? Hello, can you hear me?
Yes, we can hear you.
All right, cool. So look at what I did here. So we've created the deployment. I told you this is the deployment and this is the name of the deployment. Look at the first one. It's actually deployed to default. and then the second one is deployed to DevOps. Okay, so now we already have the deployment running. Okay, so let's use full screen. So now, come on, I think I'm already destabilized. Okay, so this was what I was trying to achieve earlier anyway. This was what I was trying to achieve after running the deployment. So you can see this is the deployment. So I told you deployment actually, what does deployment actually do? Deployment actually runs a pod. So now let's see what is actually happening. Let's see what is happening inside pod. Let's say kubectl, get pods. So you can also get pods. Let's see how many pods we have running. Okay, so we have different pods running. We have one running deployment. We have another one running inside DevOps. If I go on a full screen, this is not the best place for us. It's not the best place for us. All right, so guys, let's just do this anyway. Please, if you just have the time, okay, if you have the time, please try to work with this Kubernetes interactive. Okay, so that today will not just be a wastage. You can also learn from this Kubernetes interactive so that you can practice. I'll try to also upload the video and then we continue from there from next class. I just feel this is not going to help us very well because the screen is so small. For me, going between windows is not helpful. I have to use full screen and it's not going to.
Is there anything like this environment that one can learn Docker to? Is there what kind of environment for Kubernetes? Do we have something like Docker too?
Yes. There's Docker to Docker Interactive. Interactive. Just browse Docker Interactive shell. I think Docker even has it itself. Maybe Docker. Let's see. Oh no. There should be Docker. Get into Docker. Allow to launch Docker container. Docker playground. Okay. Yeah, just put Docker playground. Okay, yeah. So just type Docker playground, and then you see labs play with Docker. Just like you have labs play with Kubernetes, you also have labs play with Docker. So I think there's going to ask you for Docker login, and you can just connect your Docker. Once you connect your Docker registry, you should be able to take it to the terminal.
I can't see your screen, sir.
Oh, it should be your internet, I think. Or I'm sharing already. Can you see it yet?
Not yet, sir. Still the other terminal from Kubernetes.
What? Please, can another person see my screen?
Yeah,
and still play with Docker now.
Yeah, so yeah, that's it. So just once you go to play with Docker, now this is the shell. It's telling you add new instance, so you can add your new instance, and it's going to spin up an instance for you, and it gives you time. I think 4 hours. So it's still creating. So now this is it. So I think it's come pre-installed with Docker. So you see Docker PS.
Okay.
Yeah, so you can also use that. All right, guys. So let's just continue from here next week Sunday, please. Okay.
All right. Thank you.
This was not
all right. Thank you.
Yeah, this was not a good one for me. I'm really sorry for really taking your time. I still hope you still get 1 or 2 things to do.
It's part of what we done. Thank you so much for your time.
You're welcome. All right, have a good one. Bye-bye.
Yeah, bye, sir.
Let's continue. So now, secrets. I'm explaining config map. So config map is, way for passing Kubernetes environment, maybe environment variables. That's what you use your config map for. And then ingress. So ingress is just is another type of Kubernetes object for actually specifying, maybe for configuring the TLS, that's the HTTPS, the DNS, the domain name, yeah, that's what your ingress is actually helping you to do. So now let's just go straight into this. Let's go into practical. So I actually have a procedure, a set of procedure that I want us to follow here. So I just add a compilation here. So now the first thing, let's start by practicalizing. So let me just quickly show you how a Kubernetes actually works. Let me just demonstrate how Kubernetes works here. So the first thing I'm trying to do here is look at it here. Okay, take note of something. When you want to run a Kubernetes, I told you, you actually use this utility tool, kubectl. Let's see. So this is it, kubectl. Okay, so now the first thing you want to do is kubectl get nodes. If you run this kubectl get nodes, I actually do not know why AWS is not showing this, but even if you are running on Minikube, it's supposed to show you something. Okay, let me show you how it's supposed to show here. It's supposed to show all the set of nodes that you have running inside that cluster. Are you getting me? So it's going to show you, I think in the first class, I think we were able to demonstrate that with the playground that we actually installed. When we ran kubectl get node, that actually showed master and nodes are running. I think we demonstrated that. And if you want to try it too, maybe when you have Minikube or when you have on-prem Kubernetes, just run kubectl get nodes. It's going to show the number of nodes that you actually have running. Okay, so now kubectl actually works in such a way like it uses kubectl, okay, then the action, then the resources you are trying to communicate with. Now, because I'm trying to communicate with nodes, so some of the resources that we'll be communicating with most of the time, let me just write that out. So some of the resources we'll be communicating with most of the time is nodes, okay, deployments, just like you have here, all these they are resources. So you definitely be communicating with them as well. Deployments, ports, ingress, and so on. Then some other one you actually want to communicate with. Some other ones you actually want to communicate with is namespace. So I will explain the concept of namespace. We have namespace. So what is a namespace? So the concept of namespace is, a way of isolating, okay? Like you're isolating resources. You maybe there's an app, maybe bearing the same name, but the same name, you want to use the same name, but inside the same Kubernetes cluster with namespace, you can easily isolate. Okay, so now how do you do that? Let me show you. Kubectl get namespace. When I do kubectl get namespace, so now it's going to show all these are default namespace. Okay, so now you can also create namespace. So namespace is a concept of isolating inside a particular cluster. Okay, so if you want to create a namespace now, let me say you want to create a namespace and you want to deploy an app inside the namespace. So with that namespace, I can say I can deploy an Nginx inside a particular namespace, create another namespace, deploy Nginx, another namespace, deploy Nginx, and all with the same name and all. So, boss, please, can we have last week video? There is a little gap between the first class on this topic and today's class, and I guess it's last week Sunday class because I was not in the class. Oh, I actually thought we didn't do much last week. That's why I didn't really upload the video anyway. Last week we were only just trying to troubleshoot why the EKS was not working. So that's what we did basically last week. That's why I didn't really upload it. But if you want, I will see if I can upload. I'll try to upload it, but that might not be. Okay. You want to say something? Hello?
If I may ask, the port that you are using, from which VM are you running?
What?
The port that you are using,
Okay.
which VM are you using to run all the commands? Is it from the Kubernetes that you created, or you created another VM entirely, then you are using that to connect to a particular service?
Still the same VM, the same EC2 instance. So just like you have your EC2 instance, okay, so all you just have to do is spin up your EC2 instance, okay, and run this particular command here for creating your Kubernetes cluster. Just this is the command here. So you just specify the name of the cluster, then here, the region where you want to deploy the Kubernetes. In our case here, I'm using this particular region, so it depends on the region you are using. Let me show you. So now this is the region I'm using. I'm using Tokyo, as you can see, and this is the code AP Northeast. Okay, so specify the region and oh, this is it rather, sorry. So now EKCTL creates cluster, then the name of the Kubernetes cluster you're creating, okay, then the region, and then the version. So you can just take this out without notebook, or just see, okay, you can just use it, but I don't think it's actually necessary. I don't think it's actually necessary. So the most important thing is the name of the cluster, then the region, and then the version of the Kubernetes that you want to run, which is 1.23. So once you create that, just go to that particular region, under EKS, and then you see it's running. It takes about maybe 5 minutes. You see it, you see the status. The moment you run it, you see it creating. And once you see it as active, just run this. You don't need to specify the role. Just run. You can just take out the role. So all you just have to do is just run EKS, AWS. Okay. After you run this one I don't like doing before the class, but I discovered if I didn't do it before the class, I might run into issue. But that's why I like to do everything before the class so that you can see it as I'm doing. But basically, that was what I did. So you run this, then once you run that, the next thing you want to do is AWS configure. So once you run this AWS configure, it's going to ask you for okay, let me run it so that you can see. It's going to ask you for access key and secret. It's going to ask you for access key and secret. And I think from the first class, we were able to do that. Let me show you. So how do you do that? Just come here. IAM. I told you go to IAM. So you go to IAM, you create a user. Once you create that user, let me just show us. So you actually see everything actually has a trade-off. If I don't do it before the class, I might end up running into troubles, which will actually take our time, and we discover we didn't really do much in the class. That is, we'll be troubleshooting. And if I try to run before the class, there are a lot of things that you not get to understand as well. So we just have to have a trade-off. I don't know if you get what I'm saying. Oh, sorry. Can you hear me?
Yes, we can.
All right, thank you. So now, this is so now this is IAM. I told you go to IAM, then go to users. So now this is the user I created. If you want to create a new user, you can just add user. I think we did that in one of our classes. That's in our first class. So you can just check that, then specify the name, then you tell it like access key. So with this access key, you can programmatically access the user. So once you have this, when you click on access key, it's going to generate an access key for you, which you can use to log in. So it just asks you to download. And in case you didn't do that again, there's another way you can go around that. Just once you've created the user, you can also go to click on the user if you've created it. Probably in a scenario where you actually misplaced the key or something, you can always generate a new one. Just click on the user. So click on security, credentials, and you say create an access key. Okay. So I think I can create a new access key, but I think now, I don't know why it's gray now. So if I read very well, maybe it's because I already have 2 active key. So maybe that was why it's gray. But in your case, it should not be gray. That was how I created these 2 keys. So it's going to tell you access key. So now when you look at the AWS config now, you should see it ends with V50. Look at this, it ends with V50. So you specify this access key. So you see the key, access key. And then when you hit enter, it's going to ask for the secrets. It's also part of the file. You see it inside the file that you actually downloaded. So let me run it again so you can see AWS configure. So you see it asks for access key. Then the next is asking for secret key. I've specified the secret key, which is part of the file you will download when you are trying to create SSH key, when you're trying to create access key. Okay, so hit enter. It's asking for the region you want to use. You put in the code of the region you want to use, enter, and then the output format on. So it has configured. So once you do that, the next thing is you want to connect to the Kubernetes cluster. Okay, so let's connect to the Kubernetes cluster. So this is the Kubernetes cluster. This is the command for connecting to the Kubernetes cluster, which is AWS EKS update kubeconfig. Okay, kubeconfig is the config file for Kubernetes. That's why you specify credentials, the Kubernetes cluster details. So now you're telling it to update the kubeconfig. Okay, then what is the name of the cluster, which is DevOps, in which region? AP Northeast. Okay, so once you run that, then your kubeconfig has actually been configured. Then you can always use your kubectl command. Okay, so I shared how to install your kubectl in the group. Like you should install it. This is if you go to this URL, you should see how you can install your kubectl. And also, this is how to install your ekctl. You know, this is the ekctl tool that you actually used. So you have to install that as well. So install your ekctl for utility to be able to install, to be able to spin up your Kubernetes cluster. And then the next one is AWS, this AWS command. So you have to install that one to follow this URL. Okay, am I clear?
Yes, sir.
Sorry, can I get more affirmative response? Is that one clear? Can I get a response from others?
Hello?
Yeah.
Can you hear us?
Is it clear?
Yeah, this one specifically is clear.
All right, cool. So let's go on. Everything will continue making sense now. So now, I was talking about namespace. So now, let me try to create, now, the first thing you want to do is you want to run your kubectl command. The first thing I did was check our namespace, check our namespaces. Okay, so it's going to show all the namespaces. These are default namespaces that comes by default with Kubernetes. Okay, so now if I actually deploy anything, it's going to deploy it to default. And then I can also create other namespace, you know, just like I told you, this is how kubectl command work. So if you want to run issue kubectl, this is the format, action, then space, resources you are trying to interact with, resources, and then the next thing is other options. Maybe you have other options. Okay, so now let's work with kubectl. So now what we want to do now is we want to create kubectl. We want to create namespace. So it's as simple as kubectl create namespace. Okay, so now just kubectl create namespace for help. Oh, create namespace, then the name of the namespace. Okay, let's call it DevOps. So kubectl create namespace, DevOps is invalid. DevOps a lowercase. So it's case sensitive. So it says it should be lowercase. So now you can see DevOps namespace created. Now, when I say get namespace now, so now what am I basically doing? I'm just trying to you can actually create, just like you have your Docker, Docker is a way for isolating applications. Now, inside Kubernetes also, you can also isolate, which is the concept of namespace. Like, okay, inside this room A, this is the content of room A, those interact with content of room B, like a way of isolating. That's the concept of namespace. Okay, so this is a namespace, and you see, this is the namespace that has been created. So now let's start working with Kubernetes objects, Kubernetes resources. So the first thing is, let's just start. Let's start. The first thing we want to do is let's create a deployment. So this is the command now, kubectl create deployment. Just like I explained earlier. Now the first thing we are trying to do is deployment. Let's try to deploy a deployment and see what you are going to have. So now we are deploying a deployment. Okay, and then this is the name of the deployment. We are giving it a name called Kubernetes Bootcamp. Actually, I'm just following the tutorial from this Kubernetes before I go deeper from this Kubernetes interactive command line tutorial that I shared with you. So let me just quickly run a few things with you, and then we go deeper. So now we are just specifying the name. So the name of the deployment is called Kubernetes Bootcamp, and then which image are we using? So just like we specify image in our Docker, so what's the image? So it's telling us like this image is living inside gcr.io, Google Samples, Bootcamp, and Kubernetes Bootcamp version 1. That is the image you are using. Okay, so let's run this command and see. Okay, now before I run this command, let me do kubectl get deployment so that you can see get deployment. You see, it said no resource found in default namespace. Okay, no resource found in default namespace. Let me deploy this. Oh, sorry. Let me deploy this Kubernetes deployment now and see. Automatically it's going to install it in that default namespace. Okay, now let me do kubectl get deployment now. All right, so you see we have something running, right? We have something running now, but take note, it's actually deployed it inside default namespace. Let me quickly show you something. Let me show you something. Now, if you run kubectl get deployment, what it automatically does is it search for deployment inside default namespace. If you don't specify which particular deployment, or if you are trying to search for resources and you specify the namespace you're searching for, it automatically assumes you are searching for it in default namespace. Okay, so now if you want it to search for a particular namespace, you just say -n, then space name of the namespace. So look at it now, because it's not deployed inside DevOps namespace. So you see, it says no resource found in DevOps namespace. Before it says no resource found in default namespace, but now it's telling us no resource found in DevOps namespace. Now, another thing you also want to consider is how do you now specify which namespace it should deploy to? It's as simple as just saying n DevOps. So, since it's inside different namespace now, so we can still use the same name. So you see, I just created this, I created it inside DevOps namespace. Now let's get deployment inside DevOps namespace. So you see, so we have something, right? So you see, we still have inside this DevOps namespace, we have another instance of deployment called Kubernetes Bootcamp. It's going to make more sense as we go deeper, but just try to follow me as I'm going. Okay, so now look at what we've done so far is we actually did our first deployment inside default namespace because we didn't specify particular namespace we wanted to deploy. And the second deployment we did was we specified a particular namespace. Okay, so now let's now check for deployment that is existing inside all namespace. It's as simple as just saying kubectl get deployment. You say all namespaces. So with this behavior, you can just tell it like search for deployment in all namespaces. So you can see it says, look at it now, namespace. Look at these are the keys, right? These are the headings, namespace, the name of the deployment, is it ready? Is it up to date, available, and the age? Okay, so look at it now. The first one is, it says it installed it inside default namespace, and then the second one is inside DevOps namespace. It's as simple as that. So if you know, I think another shortcut for specifying all namespaces using -a. It's a shortcut using -a. Okay. Then another shortcut for namespace is kubectl. You know, I was saying kubectl get ns. NS is a short form for namespace. Okay, so, but I may not be using these shortcuts because I just want you to understand these things very well. So I just quickly show you that in case you just use some of these things sometimes, just know like at times shortcuts actually works. Okay, so but for this class, I'll keep on using the full command so that you not get confused. So now, what is really happening is telling us it is not yet ready. That's why you have 0/1, and then you have 0/1 here. So why is it not yet ready? Why is it not yet ready? Let me see what is happening. Oh, sorry. Get deployment. Maybe it's still trying to pull the image. So in case you don't know what is happening, another thing you want to do is now it's not yet ready. Then what is happening? I really need to know what is really happening. So there are some other things that you could use. There are some troubleshooting commands that you might want to get yourself familiar with, which is get. You already know what get is. Then you also have describe. You can also describe a particular object. Then you can also get logs. You can also get logs. And then we also have events. Okay, we also have events. So let's just go through all these things now. Let's just try to troubleshoot why is it not yet ready to see what is really happening. So the first thing I actually want to do here is let me get events. Let me see what is really happening inside this particular namespace, DevOps namespace. The reason why it's not ready, I can just say kubectl, or let me just say kubectl. Is it get event? Get event. Get event. Okay. So now I just say kubectl get event. So since I didn't specify namespace, automatically it's getting events inside the default namespace. Am I making sense? Hello, am I making sense?
Yes, sir. Yes.
All right, cool. So now I didn't really go further. I don't know why is AWS just so troublesome. So I have to specify nodes. So now look at what he's saying. He said pods. He said pod Kubernetes Bootcamp, no nodes available for schedule pods. So he's telling us no node is available. In the beginning of this class, we actually run kubectl get nodes. And it actually showed nothing. You remember, right? And I was telling you like what is really happening. So that is the problem. It doesn't have node running inside the cluster. To be honest, I don't know why AWS is just so problematic like this. So normally by default, it's supposed to create node. Okay, so now when you come to the Kubernetes cluster, you can come to the resources. Okay, so this is the compute. It actually says no nodes. These are the resources, no ports. Okay, fine. So now inside the cluster, this is the cluster that we created earlier. We have the overview, we have the resources. So when you look at it now, you see these are some of the things I even explained earlier. So you have the port, directory card set, deployment, ports. So now it's telling us this is like a dashboard. Cool. So it has a dashboard already. So inside the dashboard, you can even see the nodes. These are the namespace. The cluster does not have any namespace or don't have permission to view them. Why? Well, this is another thing I'll have to figure out anyway. But then let's just try to figure out the issue with these nodes. I really have to specify nodes. So no nodes available to schedule ports. So I have to specify nodes. So that is compute. So add node group. Okay. Let me call it DevOps. Select row. What's really happening here? Kubernetes state, Kubernetes label. Select the IAM role that will be used by the nodes to create a new role. The selected role must not be used by a self-managed node group, as this could lead. Okay, let me see, maybe I could attach it to the role that was created. Why is AWS just crazy for me, to be honest? It's giving me issues. So let me try to attach it to this. Let me see. Permission, is there a permission? I don't want to give it admin anyway, so I try not to give it admin. AWS EKS worker node policy. Should this be enough? Policy allow EKS worker. Okay, so let me just do this. Since I already know what the issue is anyway, let me just try to figure out how to go about it. I'm going to figure out how to go about it. Let's go through it together. So no nodes available to schedule ports. Okay, so EKS. So no nodes available, and let's see how to go about it. So I try to create EKS Kubernetes cluster, for example, using this. What I get is all ports are pending. What is wrong? So I was still having issue with the code where the worker needs register. I did not want my worker to be in public subnet. So keeps it here. I was still having issues with the EKS subnet. We highly recommend using module instead. This is using Terraform anyway. Consider sharing some more info, for example, if CTL cost cluster info, fortunately the module GitHub, now the cluster works. Fortunately, the module GitHub Terraform AWS would be Terraform AWS EKS helped. Oh, hey, now he's telling us I should use Terraform, and we've not even done Terraform anyway. Well, let me just see. Maybe there's another way around it. As Matt mentioned, it's Terraform helped. So now this is actually Terraform, which is something we should do maybe at the end of the class. So I'm not going to use Terraform to create AWS right now. I just want an easy way. To be honest, AWS is crazy. So kubectl get service. So kubectl gets nodes. So this is somebody complaining, another person complaining. Okay, so get nodes give no resource found. It was as CloudFormation created ECS. Do you mean CloudFormation created EC2 instances? I see cluster. Oops. CloudFormation and Terraform is actually infrastructure as a code. It's infrastructure as a code. So CloudFormation is actually AWS proprietary language anyway. Is a proprietary language, okay? But Terraform it supports majority of these clouds, AWS, GCP, Azure, but CloudFormation, Terraform supports virtually all the clouds, majority, but CloudFormation is for AWS. So that was, I didn't really want to talk about CloudFormation because it's for AWS. At times, you might want to work with GCP. Right now, I'm working with Terraform because I'm working in Oracle environments. So I'm using Terraform. So that's why I actually intend to use Terraform. At least you can easily deploy it, which is going to be the last topic of this class. It means there is no available nodes in this system for pods to be scheduled. Can you provide the output of yes? So following steps described in the local cluster should give, if your node is there, you should be just not ready. You can look at log. Now, once you actually spin up an instance, let's take for instance, look at this now. By default, you should have it. By default, start. So let me start the Minikube. If you install Minikube, this is how you start your Minikube too. Okay, I think we did this in the first class. So it's running. After this is completed, we can just run kubectl get node so that I can show you. But while this is running, let's just try to figure out what's really happening. So on top my head, 3 things can cause AWS host might not set up properly. Make sure kubectl get CM, kubectl AWS host exists and contains the right name, giving the CloudFormation output. This is the CloudFormation. Is it like I can't create without using Terraform? I'm working with local server. I'll try running my first Kubernetes environment following this doc. Okay. Message, deployment. So additional information. I'm trying to set up EKS following instruction in this, but while trying to set up the data, I don't have nodes and don't know why. Yes, I made sure that CloudFormation stacks for my nodes as exact name of the EKS. Yeah. So what was the solution provided? Come on. Honestly, I'm eating AWS already. Oh. This is how it's supposed to show anyway. You can see this. This is how it's supposed to show. And you can, okay, this is done running. So if I run this command, look at its Minikube ready. This is what we're supposed to have it. So, but in this our case, it's not showing. I was even thinking maybe AWS was hiding it, as Matt mentioned. Terraform, no, come on. No nodes available to schedule pods, troubleshoot pods, status. How do you troubleshoot? Okay, so now, this is, let's just go through AWS tutorial itself. This is AWS tutorial. I think I have this, I have one AWS tutorial. Where is it? Where did I keep the AWS tutorial? I think I have, one AWS tutorial. Okay, fine, no problem. Yes, there are tutorials. So we are going to follow AWS tutorial anyway. Let's see how to spin up EKS. AWS EKS. So you can see what I'm saying about AWS. You actually have 3 options. AWS EKS. AWS EKS creates. You have 3 options for creating AWS EKS. Okay, so this is option 1, AWS CLI. The second one is console, and then this is what we used. So, and which is what I run here. Subnet without node group. Okay. So cluster provision takes several minutes, and then this is what we actually did. You create cluster name, region, version, VPC private subnets. This, then keep config, get service, of course. Then why not get nodes? Please, I'm coming back. I have an emergency. All right, no problem. So we start session. Get SVC. So what's happening? So recommend to use AWS EKS add-on to enable the Kubernetes. Come on. This is not supposed to be happening, honestly. Same thing we did. Recommended to use Amazon EKS. If you deployed your price exercise, you can skip this step. Recommended next step, the IAM user role, enable secret encryption, computer login to this page help. Sorry, I don't know.